So let's start with the question 21. Question 21, they ask you to find the real value of x for which f of x equals 0. So be careful for this type of equations. They're telling you f of x equals 0. That means f of x equals 0. This is the y value, which is the same thing, the y value, which is here is f of x. So how are we going to solve this one? So they're telling you f of x equal 0. And here is the function. The function is f of x equal 40 minus 5x. So I already know they're telling me f of x equals 0. That means this value equals 0, which is the y value. Every time when you see f of x is the same thing, the y value. X and y value. That means this is f of x. So now f of x equals 0. So I'm going to plug in 0 here and equal 40 minus 5x. Now I need to solve these equations to the x. How I'm going to solve this one? Let's move the x to the other side. So I'm going to add 5x. I'm going to add 5x. This is cancelled. So it's going to be 5x equal 40. Then next step, you're going to divide both sides by 5. That means x is going to be 40 divided by 5 is going to be 8. Because they ask you to find the value of x, which make f of x equal 0. So now this is the value of x equal 8. Exactly the same thing with the 22. Find a real value of x, which f of x equals 0. So we're going to do exactly the same thing, but now this part, it's like rational equations. How are we going to solve that? So question 22, you're going to do exactly the same thing. You have f of x equal 4x minus 3 over 7. And they ask you find the value of x when f of x equals 0. So I'm going to plug in f of x 0 equal 4x minus 3 over 7. Now here's the main thing. How I'm going to solve this one to find the value of x. To solve this one, we're going to just multiply by the least common denominator. So the least common denominator here equals 7. So I'm going to multiply both sides by 7. Like multiply the whole thing here by 7. So it's going to be 0 times 7 equal 4x minus 3 over 7 times 7. 0 times 7 is going to be 0. On the other side, you're just going to cancel the 7 with the 7. So the left in this case, 4x minus 3. That's mean how to solve this one. It's up to you which one you're going to move. Let's move the 4x to the left side. So I'm going to say minus 4x, minus 4x. This is canceled. So it's going to be negative 4x equal negative 3. It's up to you how you're going to solve the linear equations. So now divide both sides by negative 4. That means x is going to be equal negative 3 over negative 4. Negative divided by negative is going to be positive. That means x is going to be 3 over 4. This is the value of x. Yes.
Where did that 7 go?
Which one? This one?
Because we multiplied 0. Oh, wait, 0 by 7 is 0. Just kidding.
Yes, that's good. It's okay. You can ask. So here is a question 23. Question 23. They ask you, find the real value of x which f of x equals 0. So it's exactly the same thing. But now we have f of x equal quadratic, x squared minus 3x minus 18. And they're telling you f of x equals 0. So I'm going to plug in 0 on this side. That means 0 equal x squared minus 3x minus 18. So if you look to this side, this one is a quadratic. How I'm going to find the value of x? I need to factor this side. So I'm going to say 0 equal, I'm going to open two parentheses, 18, and here's x squared. I'm going to put x, 18. I have two options. I can use 1 times 18. I can use 2 times 9 and 3 times 6. Which option I can use to get 3? I can use this one. I'm going to say positive, negative. So if I said plus 3, and here is minus 6. Let's check the sign. Is that the right option? If you multiply these together, it's going to be 3 times x, 3x. If you multiply these two options, it's going to be negative 6x. That means add these together, negative 3x. So this is the middle term. So this is the right option. Now I have to keep going and solve. I'm going to say 2 parentheses equals 0. That means 0 is going to be equal the first one, or 0 is going to be equal the second parentheses. Let's solve this one by minus 3 from both sides. This is cancelled. So x is going to be equal negative 3. Let's solve this one by add 6 to the both sides. Cancel these. So x is going to be equal 6. This means we have two values for x for this example. For this one, here is x. They ask you enter your answer in comma, separate list. So x equal, you don't have to type x again. Just say negative 3, comma 6. That's it. You don't have to put parentheses. You don't have to put x equal, just negative 3, comma 6. Question 24, it's exactly the same way, but look to this one. 4 terms, 1, 2, 3, 4. We have only one way to solve 1 terms, 4 terms. How are we going to solve question 24? Alpha for the x equal x cubed minus x squared. X cubed minus x squared minus 7x plus 7. And they're telling you alpha for the x equals 0. That means 0 is going to be equal x cubed minus x squared minus 7x plus 7. I have 4 terms, so I'm going to factor by grouping. That means I'm going to group the first 2 terms and the last 2 terms. Let's check how it's going to be. 0, what's the common with the first 2 terms? The common is x. So x squared. So the left here is going to be x minus 1. What's the common with the second 2 terms? The common, if you look here, is 7. So it's going to be negative x plus 1. If you look to these 2 parentheses, they are totally different. So what I'm going to do, this positive sign, I can say it's negative times negative. Because negative times negative is going to be positive. Now that means the common between these 2 terms is negative. I'm going to take this negative out and this negative out. So I'm going to say the common is negative 7. Negative 7 divided by negative 7 is going to be just x. I took this negative sign out. The left is the other negative sign, so it's going to be minus. Now we have exactly the same parentheses. The easiest way to do that, I'm going to show you now. This is positive, and here is negative. Let's show you how it's going to be easier. If you got two different parentheses, what are you going to do? Different parentheses, what I'm going to do, I'm just going to say, change the sign here from positive to negative. Change the sign for the second parentheses. This is negative, I'm going to do it positive. And this is positive, I'm going to do it negative. So now we have exactly the same parentheses. So just change the sign for the second part, here and for the one. This parenthesis similar to this one. That's mean 0 is going to be equal x minus 1, and the other parenthesis is x squared minus 7. So now, next step, two parentheses equal 0. That's mean we have 0 equal x minus 1, and 0 equal x squared minus 7. How are we going to solve this one? We're going to add 1 to both sides. Cancel here. So x is going to be equal to 1. How are we going to solve this one? We're going to add 7 to both sides. Cancel here. So x squared equal 7. We didn't finish. We need to find the value of x, not x squared. I'm just going to switch these two so you're not going to get confused. I'm going to say x squared equals 7, which is the same thing. So I'm going to take square root for both sides. Square root for x squared, square root for 7. Then square root for x squared is going to be x. There is no square root for 7, but do not forget every time when you're taking square root, you have to add a plus or minus. That means we have two solutions from here because it's x squared, and one solution from here. So that means, you see the highest exponent 3. That means we're going to get 3 solutions, or 2, or 1, or none. But in this example, we have 3 solutions. So I'm going to say the square root of negative 7 and comma. Be careful. You see, when you type the comma, you have to get out from the square root, comma, and then it's going to be, we're going to put negative square root of 7. And again, you have to get out from the under the root, and another comma, and we're going to type the other solution is 1. That's it for this example. They ask you find the domain of the function. What's the meaning of the domain? It's mean all x values. So if you have the function, which is the input, here is the function f of x equal, let's say, 2x plus 1. Keep in your mind, what's the meaning of f of x? It looks like the bus. Okay? Look like school bus. This is the x and this is the y. The function, here is the function, is the bus take the person from home to the school. So this is f of x. The domain is the person here, which is called the input. So this one is going to be the domain. And the range is going to be our destination to the school. The school, that means going to be the range. So just imagine that. This is the domain, all the students in the bus. Here is my bus, 2x plus 1. Which students I can plug in on this one? If you look to this one, 2x plus 1, if you graph it, if you graph this one, I'm going to say 2x plus 1. By the way, f of x is the same mean y. You can say y equal, or you can y equal 2x plus 1, or you can say f of x equal 2x plus 1. So the same thing. So if you graph this function to, how are we going to type the x? This is the x. This is the bottom here is x. So 2x plus 1. Let's see the graph. Then let's do these steps again. You're going to say y equal, type the function, and then you're going to hit this one. It says a graph. So check our graph. Our graph must look like this. Let's analyze this graph. Let's see which x value exists here on the domain, because they ask you to find the domain. The domain is going to be equal. This side of the graph, this is positive x, this is negative x. This side of the graph, if you take it to the x, if I take this side to the x, goes to the negative infinity. If I take this side of x of the graph to this side here, goes where? To the positive infinity. That means the domain, which is the x value of the graph, just the x value, because each point here is xy. Each point here is xy. I need to find just the x's. Just the x's on this graph is going to be the domain, which is negative infinity to positive infinity. So negative infinity to positive infinity. I'm going to put parentheses. So this is the domain for this one. If they ask you find the range, we need to find the y point, the y in each point. So we're going to do exactly the same thing, but now we're going to take this one to the y coordinate. If I took this side of the graph to the y, it goes to the negative infinity. If I took this side to the y, this goes to the positive infinity. That means the range for this graph is going to be negative infinity to positive infinity. I'm talking about only this function. Now we need to learn how we're going to find it with other question like question 25. Question 25, we're going to do the same thing. And you will see it's going to be easier by solving examples. 25, they ask you find the domain. The domain for this function. G of y equal square root of y plus 6. Don't confuse yourself. Now, the difference between this one and this one, g is the function, y is the input. That means here, x inside the parentheses is x, which is the domain. And this function between the parentheses is y. That means the input is y. So on this side is going to be y. It's just different variables. That means this is the input, which is the domain. It depends about which variable here. That means if you want to graph it, this is 26. This is 26. I'm going to go back to 25. So that means here is the assembled graph. The input, which is the domain, is y, because the parentheses here is y. That means from y to another destination, we're not going to care about that because we need to find just the domain. Keep this one in your mind. If you want to use the graph, it's fine. But in this case, when you have square root of this one, how are we going to find the domain without a graphing? To find the domain in this case, when you have square root, I'm just going to say, take everything under the root greater than or equal 0. Always you're going to use exactly the same thing. What do you have under the root? Put it greater than or equal 0. Then you're going to solve this inequality. How are we going to solve this inequality? By minus 6 from both sides. Then this is cancelled. That means y is going to be greater than negative 6. Now let's write down the domain, then we're going to check that in the graph. The domain is going to be equal. Y greater than or equal. Greater than, that means going to this side. Y greater than negative 6. I'm going to put a bracket because there's an equal sign. Greater than negative 6. So the domain starts from negative 6 and goes to the infinity. Always you're going to do exactly the same step when you have square root. Now let's check that within the graph, and is that our domain? So if I want to graph it, I'm going to say, I'm just going to clear this one. So I'm going to say square root. How are we going to type the square root? The square root, you're going to press the second function here and x squared. So this is the square root. Type y, x, it doesn't matter. It's the same variable plus 6. So because I can't type y, I'm going to say it look like x plus 6. Then a graph. Check the function. If you look to this function, here's the graph, and we need to write down the domain. That means all x's value. All x value on this one start from negative 6. That means the function starts from negative 6 and goes to the positive side, to the infinity, because here is infinity, here is negative infinity. So start from negative 6 and goes to the infinity. Why I put a bracket on this side? Because we have equal sign. So when you have equal sign, you're going to put a bracket. So this is the domain for example 26. So which one are you going to choose? This one, or you can choose y greater than or equal negative 6. You see, all real numbers y such that y greater than or equal negative 6. So this one is going to be the right one. This is example 26. We're going to go back to example 25. Example 25, you have f of x equal 3x squared plus 2x minus 2. Let's check example 25. Now we have a quadratic equation. How are we going to solve this one? It says f of x equal 3x squared plus 2x minus 2. So we need to find the domain. The note for this one, every time when you see x squared, the domain for this function is going to be negative infinity to positive infinity. Let's check that. If you graph this function, let's graph it. Y equal, I'm just going to clear this one, 3x squared, x squared plus 2x minus 2. Graph, check this function. How does it look like? The function is look like here. Like this. Let's check this one. How we can analyze that? The domain. The domain, that means I need to find all x value. So here is the first part. If I took this side from the function and put it on the x coordinate, this goes to this side. So if I took this side here, the function is going to be goes to negative infinity. If I took this side from the function and put it on the x coordinate, because I need to find the domain. So if I took this one here, the function is goes to positive infinity. That means the domain from negative infinity to positive infinity. If you need to find the range, we can check that next section on the graph, and we're going to find the range. But the range for this one, that's mean y coordinate. On the y coordinate, the function starts from this point and goes up. We're going to check that when we need to find the range. But now we're just going to find the domain. So that's it for this question. We're just going to type here. He said all real numbers except x equal to 3, or it says here all real numbers x. So this one is the right option. Let's go to the next one. 27. How are we going to work on example 27? How are we going to find the domain for this one? Let's graph this function, because this one is not square root. If we have square root, we're going to do take everything under the root, put it on the side greater than or equal 0. But in this example, it's not square root, it's a cubic root. Find the domain of the function. The domain of the function f of x equal the cubic, not f of x, it's f of t equal the cubic root of t plus 4. So now check. The input is t. That means the domain is this one, is the t. This is the domain. Not x, it's t now with this function, which is the input. So this is our domain, the input. For this one, if you have a cubic root for any root, let's graph this one to see where is the domain. It's the cubic root. How are we going to find the cubic root, or how to type it? You're going to go to the math. There's a math here. Click on it. Scroll down. There's n root and there is cubic root. So I'm going to cubic root of t. I can't type t here, so I'm going to say x, which is the same thing because it's a variable, plus 4. Graph. Now check to this function. Here is our function. Let's find the domain. So the function is going to be look like this. From here, look like this is our first side and this is the second side. So now we need to find the domain. Let's put this one on the side. So the domain, that's mean all x value. If you look to this function, this side goes, it already goes to negative infinity. And this side is already goes to positive infinity. That's mean the domain is going to be negative infinity, positive infinity. Always keep in your mind with the infinity, you have to put parentheses, not a bracket. So that's it for this question. So I'm going to say all real numbers. The domain is going to be all real numbers t, because our input is t. That's it for this question. 28 and 29 is going to be the same thing, the same way to solve it. So let's work on the 28. Let's work on 29 first, then we're going to go back to 28. Let's find the domain for 29. 29, it's a rational function. So keep in your mind, if you have rational function, you have to do exactly the same steps I'm going to do now. Find the domain. We have h of x equal 8 over x squared minus 6x. Let's find the domain for this one. Every time when you have a rational function, how to find the domain? To find the domain, we need to take this value. We need to find which value you're going to plug in instead of x to make the function is undefined. So I'm going to take this number out and consider all the rest of the numbers, except the value I'm going to find it here. How are we going to find the value? I'm going to take everything here, x squared minus 6x, and I'm going to say not equal to the 0. Or you can say equal to the 0, it doesn't matter. But we need to find this value. So I can take all the numbers except these two values. Except these two values. Now I'm going to solve this one. I'm going to take the x as a common. Don't confuse yourself here. You can make it equal sign. It's the same thing. But the main thing I put not equal, that means I can take all numbers except the result from solving these equations. So I'm going to solve this one on the side. Take the common between these two terms. So it's going to be x minus 6, not equal to the 0. Now I'm going to say x not equal to the 0 and solve the other side. If you want to keep it as an equal, it's fine. The main thing, solve this one. And solve the other one, x minus 6 equals 0. That means you're going to add 6. So x is going to be equal 6. That means I can take all numbers except 0 and 6. That's why I put not equal, not equal, not equal here, not equal here. That means you can take all numbers except 0 and 6. Why? Let's check that. If you plug in 0 here, if you said h of 0, that means I'm going to plug in 0 here. So it's going to be 8 over 0 squared minus 6 times 0. 0 squared is 0, 6 times 0, 0, 0 minus 0. So it's going to be 8 over 0. Any number divided by 0, it's undefined. That's why we can't choose the 0. Now let's plug in the 6. H of 6 is going to be 8 over 6 squared minus 6 times 6. 6 squared is 36. 6 times 6, 36. So it's going to be 8 over 0, which is also undefined. That's why we can't choose 0. We can't choose 6. That means the domain is going to be all numbers except x equals 0 and x not equal to 6. You can choose all the numbers, 5, 6, 100, million, negative million. All the numbers is going to be works except these two values, 0 and 6. If you look here, you can choose all real numbers except 6, all real numbers except 0 and negative 6, all real numbers except 0 and 6. That's mean all real numbers except these two values. So if you want to put equal sign, it's going to be right. The main thing, you're not going to choose these two values. If you put not equal sign, it's fine. That means you can choose all the numbers not equal to the 0. That means 1, 2, 3, 4, negative 1, negative 2, and keep going, except 6 and 0. Find the domain of this function, 1 over x minus 2 over x plus 5. So this is a question 28. We're going to find the domain for this one. G of x equal 1 over x minus 2 over x plus 5. How are we going to find the domain? I have this part is a rational and this part is a rational. So what I'm going to do, I'm going to take each part and equal it to the 0. I'm going to say for this one, x equal or not equal to the 0, that's it. That means I can't choose x in the domain. I can't keep x in the domain equals 0. I have to take the 0 out. The second part is x not equal x plus 5 not equal to the 0. I need to solve this one. X plus 5 not equal to 0. That means x not equal to negative 5. That means on this one, to find the domain, I can choose all numbers except 0 and negative 5. So the domain is going to be all real number except x equals 0 and x equals negative 5. I can choose these two numbers. That's it for this question. So all real numbers except negative 5 and 0. That means this is the right option. You see this one, only x equal negative 5 and x equals 0. This is the wrong option. We can choose all numbers except these two numbers. Let's keep going. These are two real important examples. Example 30 and 31. Because we have rational and we have radical, which is the square root. Rational and radical. So this is two important questions. Let's work on these. Find the domain of the function for this one. F to the S. Question 30. It says f to the S equal square root of S minus 4 over S minus 7. Keep your mind on these two are really important examples. For this question, f to the S, S minus 4 and S minus 7. As a radical, I need to find here in the radical. So I'm gonna do it like this. For the radical equation for this part, S minus 4. To find the domain, I'm gonna take everything under the radical, S minus 4 greater than or equal to the 0. Greater than or equal to 0. So here's the first one. Now go ahead, solve this one. So S, you're gonna add 4 to both sides. So S is going to be greater than or equal 4. That means the graph start on this part, on the top part, start from 4 and keep going to the positive side. Let's check the other side. Now I have rational here, S minus 7. For the rational, I'm going to take the bottom part, which is S minus 7, and say equal to the 0. So add 7 to the both sides. Again, if you say not equal, it's going to be the same thing. S is going to be, let's say not equal to the 7. So now I need to, because this is these two parts with the same function. So I need to add these two domains together. I need to add these two domains together. Here's, I'm just going to put a line for the x. This is negative infinity, and this is positive infinity. And let's put down the 0 here. The domain on this one start from 4. Let's say 1, 2, 3, 4. I'm talking about the x coordinate just. I'm not going to care about the y. For this function, start from 4 and keep going to the infinity. So 1, 2, 3, 4. So start from this point. Start from 4. This is 4, and goes where? Goes to the infinity. This is for this function. That means my domain started from 4 to infinity, but I can't choose 7. Because 7, if I choose 7 in the domain, is going to be make a problem here. 7 minus 7 is going to be 0. Any number divided by 0 is going to be undefined. That means my domain, you check the 7 exists here. 4, 5, 6, 7. Here is the 7. So I can choose all the numbers here because it's belong to this one, except this number, the 7. That's mean what I'm going to do. How we're going to write the domain? Check here. They're telling you all real numbers as such that s greater than 4, which is right. Here's x greater than 4, except s equals 7. So this is the right option. The second one, all real numbers, this is wrong, because with the radical, we have to write down s minus 4 greater than or equal to the 0. The third option, all real numbers, s greater than 7. This is the right option, but we're missing the second part. This is wrong, because it's supposed to be 4. So this is the right option, all real numbers, s greater than 4, except s equals 7. We can't choose the 7. So my domain is going to be all real numbers greater than 4, except 7. That means all numbers such that x greater than or equal 4, except this number, which is s, not x, except s equal 7. We can choose the 7. Or you can write down like this. From 4 to 7, domain, I can say bracket, because always with the equal sign, you can say bracket to 7. The bracket is mean this number belong to the interval, parentheses, that means this number is not belong to this interval. Bracket is mean this number belong to the interval, parentheses, it means this number is not belong to the interval. Union, another parentheses, from 7 and goes to the infinity. From 7 and goes to the infinity. Always with the infinity, you can type parentheses. So you can type it like this, you can type it like this. Both is going to be right. Because with this equation, my domain start from this part, interval, and stopped here, because I can't include the 7, and start again from 7 and goes to the infinity. But the 7 not include the graph. Even if you graph it, you will see the graph, there is a hole at x equals 7. That's it for this example. We're going to do exactly the same thing with example 31 and 32. 32, find the domain of the function. Here is our function f of x equal x minus 1 over square root of x. So question 32. How are we going to solve this one? F of x equal x minus 1 square root of x. This is rational equation, and on the same time, the bottom part is a radical. So how are we going to find the domain? We already know if we have radical, we're going to say it's equal, greater than or equal to the 0. So in this case, because the radical on the bottom part of the rational equation, so to find the domain, we're going to say that x, we can take everything here, greater than, but I can't put an equal sign here. Because remember, if you have just x, you're going to say x not equal to the 0. But in this case, I have radical here, so I can't say x greater than or equal to the 0. Because if it's equal, that means I can plug in 0 here. The square root of 0 is going to be 0. Any number divided by 0 is going to be undefined. In this case, I'm not going to put the equal sign. That means I can choose all the numbers greater than 0, which is 1, 2, 3, 4, and keep going until the infinity. I can't choose the 0, because if I choose the 0, which is mean the equal sign, is going to be square root of 0, which is 0. Any number divided by 0 is going to be undefined. That's why the domain is going to be all the numbers greater than 0. So all numbers x greater than 0. This is the domain. That's it for this question. All the numbers, you see here, x greater than 0 and x equal 1. We can't choose this one. X equal 1, all the numbers such that, here's all real numbers x such that x greater than 0. That's it for this question. The same thing for 33. 33, it's a rational and we have radical here. How are we going to find the domain for this one? So let's do this one. Question 33. It's f of x equal x plus 2 over square root of x minus 8. So here is the radical, and on the same time, it's a rational. So let's check that how we're going to find the domain. So if you took x minus 8 greater than, we can't put equal. Why? Let's check that. If you put equal sign 0, solve this one, you're going to add 8. So it will be x greater than or equal to the 8. That means our domain starts from 8. But we can't choose the 8. Why? Because there is a radical and on the bottom part. If you choose 8 here, it's going to be 8 minus 8, 0. Square root of 0 is going to be 0. Any number divided by 0 is going to be undefined. That's why when you have radical on the bottom part of the rational, do not put equal sign. That means the domain starts from 8, from 9, x greater than 8, which is 9, 10, 11, 12. So we can choose 9, we can choose 10. If you choose 8, it's going to be wrong. So this is the case when you have radical on the bottom part of the rational function, you can't put equal sign. So that means all real numbers such that x greater than 8. That's it for this one. F of x equal, if you see this type of functions, f of x equal 2 parts. If you see this type of the function, this is mean function with 2 parts. So always we're going to call this function is the piecewise function. So you see, because this function, the first part is 2x minus 1 when x less than 0. That means when x is negative numbers, you're going to use this part. When x is positive number or equal to the 0, you can use this part. That's why it's called piecewise function. So I explained that in the first part of this record. So this is the piecewise function, and we plug in some numbers. So this is an example of piecewise function. Then choose this one. That's it. This is the important thing, how to use the different quotient for this function. In fact, there's a definition of the different quotient that's telling you f of x plus h, f of x plus h minus f of x over h. They're going to ask you, and there's condition always h not equal to the 0. H not equal to 0 because any number defined by 0 is going to be undefined. This one is called difference quotient. So on the test, they're going to tell you use the difference quotient. That means you have to use this one, the difference quotient. Use the difference quotient to simplify. Here is our function. We're going to use this one. So f of x question 35. F of x equal 6x minus x squared. How are we going to use this difference quotient? So first of all, you see these two parts? Let's write down this one. F to the 6 plus h minus f to the 6 over h. That's what we need to find. So that I'm going to find the first part, this one. Then I'm going to find the second part and plug in everything here. So I'm gonna, this one is the star. That's what we need to find. I'm gonna go ahead and write down the first one. The first part is f to the 6 plus h. What does that mean? f6 plus h. I have f to the x equals 6x minus x squared. I'm going to plug in 6 plus h instead of each x here. 6 plus h instead of each x here. So it's going to be 6 parentheses. I have an x, so I'm going to put 6 plus h. 6 plus h. Close the parentheses. Minus x squared. I'm going to open parentheses. I'm going to put 6 plus h. I'm going to close the parentheses. So what I did, this is x. This is 6x minus x squared. See, everything here is x. Everything here is x. And everything here is x. So I'm going to plug in 6 plus h instead of each x here. Then we have to simplify it. First of all, how are we going to simplify this part? By distributing. So 6 times 6 is going to be 36. 6 times h is going to be plus 6h. Minus. Be careful here. How are we going to simplify this one? To simplify this one, we'll go ahead on the side. I'm going to open two parentheses. 6 plus h, 6 plus h, and FOIL it. 6 times 6 is going to be 36. 6 times h is going to be 6h. H times 6 is going to be h6, which is the same thing, 6h. H times h is going to be h squared. That means I'm FOILing, so I'm not going to confuse myself. Then I'm going to bring back everything here. So this is minus parentheses. Do not forget you have to put parentheses because when you FOIL it, the sign is going to be distributed on each term here, which is 36 plus 6h plus 6h plus h squared. Then next step, I'm going to FOIL 36 plus 6h. Negative times positive is going to be minus 36. Negative times positive is going to be minus 6h. Minus 6h minus h squared. Now combine the log terms. Check here. I have 36 minus 36, cancel. I have 6h minus 6h, cancel. So the left from this part is negative 6h minus h squared. I'm done from this part. Now I'm going to go back and solve the second part. I'm going to say f to the 6. Then I'm going to go back to the original function and plug in 6 instead of each x. So it's going to be 6 times 6 minus 6 squared. So it's going to be 6 times 6 is going to be 36 minus 6 squared is going to be 36. So the result is going to be 0. That means this part is 0. Then I'm going to go back to the star. I'm going to say f to the 6 plus h minus f to the 6 over h is going to be equal. F to the 6 plus h, which is this part, negative 6h minus h squared. Minus f to the 6, which is 0, over h. That means is going to be negative 6h minus h squared over h. Can I simplify it? Yes. What I'm going to do, I'm going to take the h as a common between these two terms. I'm going to take the h as a common between these two terms. So here's the h. The left is negative 6 minus h over h. Now, last step, cancel this one with this one. So the left, which is going to be the result, negative 6 minus h. That's it. This is the solution for this one. So you see all these steps. The first thing, I took this part here, simplify it, take the second part here, simplify it, and add these together here by plugging just the first part and the second part, and simplify it. Here's the result. The difference between these two questions is this one, you see, it's an x in general. And this one, x, is different than the previous example because we have number here. Instead of x, we have number. So now let's work on the last example, and we need to find the result for this one. So the result is going to be in general, not like this one. So question 36, but we're going to do exactly the same steps. We're going to use the difference quotient, which is f to the x plus h minus f to the x divided by h, and h not equal to the 0. They ask you to use f of x equal x cubed. This is the function, minus or plus 3x. Now here's our function. We need to use the difference quotient. So yeah, the first thing, we need to find f plus h. That means f to the x plus h equal. I'm gonna plug in instead of each x, I'm gonna plug in x plus h. And instead of each x, I'm gonna plug in x plus h. So it's gonna be x plus h cubed plus 3x, which is x plus h. This is the first part. Let's simplify this part. How are we going to simplify this one, and how are we going to simplify this one? This one is just going to distribute. But what about this one? How are we going to simplify x plus h cubed? Let's do it on the side. So x plus h cubed is the same thing, x plus h, and x plus h. 3 times. FOIL these two parentheses, and then FOIL the result with the third parentheses. I'm going to say this is x plus h. Open another parenthesis. I'm going to FOIL this one. X times x is going to be x squared. X times h is going to be plus hx. Or xh is the same thing because it's multiplication. You can switch it. Then h times x is going to be hx. And h times h is going to be h squared. We're done from this one. Then I'm going to FOIL this one and everything here. So x times x is going to be x cubed. X times hx is going to be plus h x squared. X times hx. Before that, can we add these together? It's going to be easier if we add it. Let's add it. Because we have like terms. It's going to be the same thing. Because you can add it after that. So x squared plus 2 hx plus h squared. Now we're going to distribute. X times x is going to be x cubed. X times 2hx is going to be plus 2hx squared. X times h squared is going to be plus h squared x. We're done from this one. Let's distribute the h. H times x squared is going to be plus h x squared. H times 2hx is going to be plus 2h squared x. And the last one, h times h is going to be plus h cubed. Let's check. Do we have like terms? Yes, we have this one similar to this one. You see h and x squared. And we have this one similar to this one. So we're going to combine these together. So it's going to be x cubed. 2 plus 1 is going to be 3. So 3 h squared. No, this is h x squared. I'm adding this one with this one. H x squared. And h squared, which h squared, so it's going to be also plus 3 h squared x plus 3 h cubed. So this is the result distributing these three parentheses. The same thing start with the first two parentheses, combine the like terms, then distribute the third one on the second polynomial, then combine the like terms, and here's the final result. I'm gonna write down this, the whole thing here. So this one is going to be only this part. So h cubed plus 3h x squared plus 3h squared x plus h cubed. Let's keep going on this part. We have distributed 3. So it's going to be plus 3x plus 3h. I'm done from this part, the first part. The second part is just f of x. So here is f of x. We don't have to plug in everything here because f of x is the same function. Now I'm going to plug in this part and the function here. That means f to the x plus h minus f to the x over h is going to be equal. F x plus h, the first part is going to be the whole thing here. That means it's going to be x cubed plus 3hx squared plus 3h squared x plus h cubed plus 3x plus 3h over h. We didn't finish. Minus f of x, which is the function, which is x cubed plus 3x. And be careful here, the minus parentheses, because you're going to distribute the negative sign, which is next step. So this one is going to be equal. You have to take your time when you're doing these examples. X cubed plus 3hx squared plus 3h squared x plus h cubed plus 3x plus 3h minus x cubed minus 3x. And disputing the sign and everything over h. Now let's check. Do we have the same term? If you look here, x cubed minus x cubed, just cancel it. 3x minus 3x, cancel it. That's it. We can't cancel anymore. So now we're gonna write down the leftover in another step. The left here is a 3hx squared and plus 3h squared x plus 3h cubed. This is the left from here plus 3h over h. Now check, I'm gonna take h as a common between these four terms, 1, 2, 3, 4. H as a common, so the left is going to be 3x squared from here, because I'm gonna take just the h. I'm gonna take one h from here, so it's going to be 3hx, so plus 3hx, plus I'm gonna take one h from here, h squared, plus I'm gonna take the h from here, so the left is going to be just a 3. And everything is going to be divided by h. Cancel this h with this one. And here's the result. 3x squared plus 3hx plus h squared plus 3. That's it for this example. This is going to be your solution. By using this definition, this one is going to be your solution. This rule is really important for the next level of math. So you're going to type here just the result, which is 3x squared, 3x, here's the squared, and plus 3hx plus h squared. So h, and here's the squared, and plus 3. This one is going to be the result for this one. That's it for this section.